welcome to Introductions to Compound Interest. Today we're going to talk about some basic problems of compound interest and how to solve for them. But before we get started, let's first get an understanding of what the compound interest is and what the formula is. So the formula for compound interest would be A equals to P times 1 plus R over N to the power of N times T. And so A is, you could just think of this as Y. I just put it as A because I want to think of everything as annual, because when it comes to compound interest, a lot of times it talks about annual stuff. And if you can see here, it asks for monthly, blah, 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 which we'll talk about later. And so I know this looks very complicated. So let's step back a bit and then look at the original formula for an exponential function. So we know that compound interest is exponential, but then if we look at just what we've learned before, we know that the exponential function would be a times b to the power of x, where a is the original value and then b would be the growth rate or the growth factor. And so if we look at this equation here, you can kind of imagine that, oh, okay, well, I know this kind of looks like, oh, it's a, right? And then if we do this and then expand on n, so you notice that I highlighted n. If we expand that, the whole thing, you could think of it as b, right? And then t would just be something like x. So it's kind of like a times b to the power of x. And so if we look at this and this, it's kind of the same thing. So now let's uncover what the specific letters represent. So as I've said, this is A, so I know that P would be the original value, or you can just call it the principal or the original value. So that means original value meaning when x or when t is 0. So in the graph, when x is 0, I know that P would be somewhere like here. So it's, if P is 5, then this would be 5, right? So that's what P is. And if we look at R, we know that R is going to be the nominal annual rate. Don't worry about the vocabulary, you'll understand more about it later. And then we know that N is just the number of compounds in a year, in 1 year. And then T would just be the time, and we want to specify it as annually. Alright, so now I know this looks super confusing. I remember the first time I did it, I was kind of drowning because it's just so confusing, right? But don't worry, let's take a look at the example and then we'll try to work through it using this formula here. So suppose you have $1,000 and it is invested in an account yielding interest at a nominal rate of 8% per year. Find the balance 3 years later if the interest is compounded. So here it says compounded monthly, compounded weekly, and compounded daily. Now the first thing we want to do is try to use these numbers and first put it in the formula. So we have 1,000. That means invested in an account. So we know that the original value would be 1,000. So P would be 1,000. So it would be something like 1,000. 1,000, right? Times whatever that's inside. And then here it says nominal rate of 8% per year. So we know that this is the nominal rate, right? So then we know that R is going to be 8%. But be careful, it's 8%, not 8. So if we put it in decimal form, it will be 0.08. Or we could always write it as 8 over 100, which is the same thing as 0.08. So we know that R is 0.08. And then here it says if it's compounded monthly. Now be careful here. This is the part where a lot of people get it wrong. So let me just first write it as N. So let me just, my pen is not working for some reason. Okay. So I'm just going to put it as N times T, And we'll solve for the t later. It asks for 3 years, but first let's put everything in. Let's put all the numbers in first. So what n is the number of compounds in a year. And so what we want to do is kind of convert years into months. So what I want to think about is everything is annually right now, but here it's asked for monthly. So I'm going to ask myself, how many months are in a year, right? Or how many weeks are in a year? Or how many days are in a year? And so for the first one, how many months? I know that there's 12 months. From January to December, there's 12 months in a year. So you can put n as 12. And then here, n is 12 times t. So we completed our formula. And now we want to plot 3 years later. So what that means is I want to solve what's y gonna be if t is equal to 3. And then I can use my calculator from here. And so if I use my calculator, I get something like 1,270.24. So if I compound it monthly, after 3 years, I would get this much money. Now if I say weekly, let's try weekly. Oh, oopsie. Okay, let's move this out of the way. Let's try doing it a little bit smaller. Okay, if it's weekly, the same thing applies. We start off with the 1,000, and then we have 1 plus 0.08. Everything remains the same, but n does not because it asks for weekly. So how many weeks are in a year? 52. So then it would be 52 times t, which is 3, right? We want to solve for 3 years, the value after 3 years. And so we get something like 1,271.01. Now let's try daily. Try doing it yourself. You can feel free to pause the video if you want. All right. And so for daily, the same thing again. We start off with the same value, and then we yield a nominal rate of 8%, which is the same as what we did before. Again, this time I want to know how many days are in a year. So we're going to assume that there's no leap years, so just assume it as a normal year. It would be 365 days times 365 times 3. And so at the end, I should get 1,271.22. And so here you can kind of see the trend, right? If I compound it monthly, let me just make it so that it's consistent. If I compound it monthly, I get 1,270. However, if I compound it weekly, the value is greater than monthly. But if we step further and do it daily, we get even more money at the end. So you kind of see the pattern of how in monthly and weekly and daily, how the values are slightly different. And so this is just some basics of compound interest. Thank you for watching.